All right, can't get enough buoyancy problems here, I think, right? Okay, so we've got the Dead Sea, right? We've got this piece of basalt, and it's submerged in the Dead Sea, and there's a force of gravity is acting down, right? So that's that, right? And then of course there's going to be a buoyant force acting up on this. All right, and so I guess let's see, what upward force would you have to exert to keep it from sinking? So that's just going to be our force like that, right? And if we set up a force equation, we would go force plus B minus mg, right? So the upward force plus the buoyant force minus the weight is 0, right? So the force is what we're trying to find out, right? The force plus, and then we've got, it's 52. Oh, we don't have the volume of this piece of basalt, but we do have its density. Okay. I've got it. So what we got to do, the first thing we got to do is we got to figure out the volume of the basalt, right? So density is mass divided by volume. So therefore volume is mass divided by density, right? So down here what we do is we go, okay, the volume of the basalt is its mass, 2.1 kilograms, divided by its density, 2920. And that's kilograms per cubic meter. All right, so here we go. 52.1 divided by 2920. And that is a whopping volume of 0.0178 cubic meters. All right, let's keep that in mind. So now we're all set. Now we can figure out the buoyant force, right? So it's going to be the density of the water, right? So it's rho of the water, volume of the water displaced of the fluid, right, times g minus mg is 0, right? So force plus, and the water is 1240, right? Remember, the buoyant force is always the density you use is the density of the displaced fluid, right? Because the meaning of it is the weight of the displaced fluid. And then 0.01784 times 9.81 minus, and then we can just do the downward force as the force of gravity. So 52.1 kilograms times 9.81, and that's 0. And of course the force is just going to end up being the difference between these two, right? So let's do this. 52.1, all right, minus all right, here we go, times, and I'm getting 294.058 newtons. Okay, so remember that all these things, like what force do you have to exert to either keep it from sinking or to keep it from floating if it's something less dense than water. You have the force of gravity down, you've got the buoyant force up, and then that unknown force is acting in whatever direction they say. In general, if it's more dense than the fluid, you'd have to exert an upward force, and if it's less dense, you'd have to exert a downward force.